SwayamPrabha. Digital India. Educated India.
Hence, huh?
Sir, here is 0.8497.
Okay, just give a second for Rajesh to come to terms with. Rajesh, is everything fine? Recording?
I started recording.
Okay. Now you are stable?
Yes, I'm checking the code.
You check the code, we will proceed with the class. Okay.
Okay, sir.
Now you check it.
Okay.
R squared is? How much is it? How much was it? R squared in LSR by removing the outlier.
.9976.
So what is the strategy you do? First, consider all the points. Work out the line. Then plot the parity plot. Plot the points on the parity plot. And just check which one has got the maximum error. If that stands out, it's an outlier, remove that and recorrelate. That's a much better strategy than to give importance to the outlier by doing the minimax. Okay. Minimax doesn't work very well. Okay. So 0.85. That's what you get in minimax. All right. So we spent a good amount of time in this. Okay. So the origin of this minimax. Any doubts so far? Subhas, everything is clarified now?
Yes, sir.
So I don't have to check your code, right?
No.
You have said. All right. Very good. Okay. So, minimax proposal. The origin is basically game theory. How many of you studied game theory in IIT? If anybody has studied, just say yes. No?
Yes.
You have studied. Okay. Maybe in Rahul Marathe's course or something, I don't know. Or Amit Kumar, huh? Amit. Okay, Amit. Okay.
Sir, not in IIT.
Not in IIT. This is some course Eras, edX something. Is that?
Sir, in BTech college.
Okay. So this game theory basically game theory is used in decision sciences. Okay. So basically the famous problem is the prisoner's dilemma. Yesterday I made a misspelling. I didn't put the apostrophe. It was wrong. Okay. So let us spend some 5-10 minutes on this famous example of prisoner's dilemma. Okay. This is a very famous example. Robbery takes place. Robbery takes place. Two suspect robbers are caught. As usual, the next stage is interrogation. The interrogation is taking place in two rooms, room 1, room 2. Okay. First robber, robber is question mark, okay? And second robber. So it is done in such a way that robber one will not know what are the questions posed to robber two and what his answers are. By the same token, robber two will not know what the questions posed to robber one are and what his answers are. Is the situation clear? Robbery takes place. There are two suspects caught by police. Investigation is going on. Interrogation, questioning, taking place in two separate rooms. Okay. So there is a chance. The police is giving a chance for the robbers to confess to their crime. Okay. They cannot communicate with each other to decide whether they will RG or not RG, whatever. Okay. So they can't play a game based on this thing because they are not allowed to talk to each other. Is the situation clear? Now the proposal by the police is as follows. If both of them say that we stole it, then each of them gets 5 years of prison. Watch this carefully. If both of them say that, because they don't know each other's answers, both of them say only I did it. Because the police plus says not clearly what the terms are. The police says that if you confess, there is a reward. That means if you are confessing, you are cooperating with the investigation. You must have read in the papers, no? The accused is not cooperating with the investigation. I had a big bout of allergy. Some of you may be able to relate to what I'm saying. This is the November to March. This is the pollen season in campus. It won't cause the problem will be only here. No? First, the eyes will become itchy, the eyes will water will come from the nose, and this region you will feel sneezing. If you take, there are medicines. You can take Allegra or Avil or something. If you take medicines, they knock you out. They just knock you down. You can't take classes. You can't do work. If you do that, within a day it will go. Otherwise, I am taking some medication in the night. The daytime we'll have to suffer. You can keep drinking some tea, but you have to get on. This online business is very difficult to reschedule classes. Anyway, but there is no other general complaint. The thing is, if you look down, I'm finished. All this fluid will flow down, right? And it's miserable. Has anybody suffered this or suffering this? It's called allergic rhinitis. Is there anybody who suffered this on campus or elsewhere? Is there anybody? You know what I'm talking about? Hello? Yeah, I have seen many students in the class. The handkerchief will be wet by the time the class is over. This is a familiar seasonal pollen grain allergy. All right, okay. Each of the burglars or the robbers are the following. If both of them confess, they'll get 5 years RI. In India, it's called RI. RI is rigorous imprisonment. SI is simple imprisonment. Okay, they'll get 5 years of prison. If none of them confesses, each one will get 1 year prison. But they won't know whether the other guy has confessed or not. If one of them confesses and the other guy does not confess, the confessor gets 0 years of prison because he has already cooperated with the police. And the non-confessor gets 10 years, okay, of prison. He pays for the entire crime. Okay, is the proposal clear? Interrogation is taking place separately. They will ask the following question: did you do it or did you not do it? Okay. If both of them say we have not, both of them say we have done it, 5 years. If both of them say we don't know, somebody else do it, you've caught the wrong two people because the police don't have much evidence. Okay. If both of them say, if both of them say we have not done it, they still get 1 year prison because there is some indirect evidence, something, whatever. If one of them says I have done it, the other says I have not done it, whoever is accepted, okay, he will get 0 years because the case can be closed by the police. The other fellow will get 10 years. Okay. The best strategy for both would be that none of them confesses, so that both of them will get 1 year jail and escape. If both of them say they've done it, 5 years plus 5 years, 10 years of cumulative jail. If one of them confesses, the other also does not confess, It's 0 plus 10 years. Total damage is 10 years of jail if you consider both of them together. Okay. So you put yourself in the robber's position, and what is the strategy you will take? So this is called zero sum game, 2% zero sum game. It is a non-cooperative game. Okay, it is a non-cooperative game because the reward is punishment. Okay, so it's a non-cooperative game, and it is a zero sum game. Okay, there is no way by which both of them can escape prison in whatever be the situation. Somebody is good, whether you want to get cumulative hit maximum or individually somebody will get minimum. That is the strategy. So put yourself in the burglar's position or the robber's position and take a call, whether when the police asks you, did you commit the crime? Did you burgle that place? Whether you will say yes or not. This is the original problem which was proposed by Professor John Nash. Princeton University, okay, 1928. Please note that he won the Nobel Prize in Economics in 1994. He had a lot of psychiatric issues, and he's the subject of the hero of the. He's the hero of the film A Beautiful Mind. Has anybody watched this?
Yeah.
Yes, sir.
Yeah, A Beautiful Mind, brilliantly acted by the Australian actor Russell Crowe. If you have not watched, if your weekend is free, should be there on Netflix or Amazon or Hotstar or somewhere. Okay, MX Player, I don't know, it should be in one of those things. Watch it, it's well worth it. Okay, but overcoming all his limitations, he did get the Nobel Prize. Unfortunately, in 2015, he and his wife are going in a taxi. I think they got into an accident and he died. But before that, he got the Abels Medal. He got the Nash was a superstar. Okay, mathematician working in economic science, and so they got a. There's no Nobel Prize in maths, right? That is a problem. Okay, so however, he got it in the Nobel Prize in 1994 in economic sciences. Okay, all right. Now, this was originally proposed by Nash. So, if the other burglar confessed, your self-interest is to confess, correct? If you know that the other person has confessed, and your self-interest is to, sorry, if you know that the other person did not confess, okay, watch it. If you knew that the other person did not confess, you will simply say, I have done it. If you say I have done it, since only one of the two people has accepted, and it is possible for the police to close the case, and since you are cooperating with the police, you will get a zero punishment. This is the best strategy for you. But the funda is, you don't know what the other fellow has said. But then we'll say that for safety, if I say I confess, because taking a chance, if that fellow has not confessed, because looks like he's a serious thief. Suppose you imagine that fellow is a crook. Okay, he will argue me. So he will say I have not done. Then in that case, if I argue, okay, I have done. If that fellow says he has done, he has not done, what will be my strategy? So I'll keep on thinking. So therefore, we are confused at what is the stand we have taken. Now, there is something called your inner urge. There is something called your survival instinct. What will you do? Regardless of what the other person will do, common sense tells you that the police is saying that if you cooperate, things will be better for you. So what he will do is, regardless of what the other person does, you will confess. He said, yes, I only did it. For the same reason, the other fellow will also say that I have done it. But what is the solution? If both of them confess, they get 5 years each of prison. Okay. So the Nash equilibrium. So this is called the Nash equilibrium solution for this problem. The Nash equilibrium solution for this problem is both of them confess and both of them go to jail for 4 years, though it is not the individual optimum for each of this. Okay. So it is not possible. So this is the minimax. Okay. I will minimize the maximum loss. I will minimize the maximum loss. That seems to be the strategy of each of these burglars. But since both of them are participating in a non-cooperative game in which they are not aware of the opponent's moves, they will decide in a fashion which they think is the best, but which will not result in a global optimum. Okay, both of them would be far better off if both of them said that, no, sir, I don't know, I did not do it. Did you do it? No, sir. Other A. B. Did you do it? No, sir. Then the case is not closed. But please look at that. The solution will be 1 year in jail. The solution will be 1 year in jail. That is a much better proposition compared to both the fellows saying that I did it, because it is natural for you to say I did it, because the police is enticing you to say. If you say I did it, I did it, you can go with zero reward. But it comes with a caveat or a condition that it also depends on the other person's response. Okay, so both of them would be better off if they said, if they had agreed not to confess, but their personal temptation of looking for a solution where they can escape with zero imprisonment makes this proposal irresistible. And then both of them confess, both of them go to jail for 5 years. So this is the minimax. This is the Nash equilibrium. Now you can all go, Nash equilibrium can be applied. If you want to go to the supermarket, that supermarket is this far off, milk and bread are this price, other supermarket, milk and bread are this price. Whether you'll go to this supermarket or whether you'll get milk from one place, bread from some other place, like that. You go to Wikipedia, there are Ajar solutions of, okay, Nash equilibrium. Now I'm 45 to 60 age group. So vaccination will open for COVID. Whether I should get it or not. If so, whether there is a choice of Covishield or Covaxin, or I should wait. I should wait and see what happens to other people who have taken the vaccine. So this is also like a prisoner's dilemma. We are also prisoners, right? 1 year we have been in prison. All of us are facing the prisoner's dilemma. So minimax is, so you can take up some decision theory or operations research. So some nice lectures may be available. If you want, you can do some courses. Somebody who's interested in analytics, business analytics, management, or even operations research and so on, wants to do master's or PhD, or you want to work in Goldman Sachs or something like that, these sorts of things will come in very handy. Okay. So where some funda is applied to behavioral science. Okay. So behavioral economics is also a very important subject now. Okay. Raghuram Rajan is a BTech from IIT Delhi, right? So he became Reserve Bank Governor. He did PhD in economics and all that. So engineers can also do many things. But you'll all be happy if you stay in engineering. But it doesn't matter. Whatever you do, if you do well, it's fine. Behavioral economics, you can look at the books by Professor Dan Ariely. You can look at the books by Professor Dan Ariely. He has written a lot of books on irrationality, the upside of irrationality. Okay. There's also a book called Freakonomics by Steve Levitt. Okay. That's also on economics. And so, do you know that book called Freakonomics? Has anybody heard about this book? So you don't read anything outside your subject, is it? You don't read at all. You read only Chetan Bhagat? What do you read? Anybody? Hello? I'll go back to the same question. Hey, why am I okay? I'm pinning myself. Okay. Okay. Why is Subhas coming? Subhas, you should not share your screen. So I will disable the share screen. Huh? What is happening? I am coming at the top. The Subhas is coming in the center of my screen. Subhas, what should we do now?
Sir, pin yourself to the screen.
Pin yourself. Huh? Wait. Pin. Then I'm able to see only myself. which is not a very good thing to do. But anyway, it's okay. Okay, this is the, I can see the board also. Okay. So please look at the books by Dan Ariely. I have all his books. Okay. He has a third degree burn or something. His face is all this thing, but been very resilient. He fought. Did PhD, he became a prof. He has given TED Talks, you know this TED Talks. They're all stud guys. Yesterday I told Adam Grant, Dan Ariely, Steve Levitt, they've all become top professors very early age. So I do a lot of outside reading, as you might very well guess. So there's a professor called Michael Sandel. He is in Harvard. So please watch his lecture, The Moral Side of Murder. So he offers the justice course. I think in Harvard or MIT, I don't know, in Harvard or MIT, he offers a justice course. This is another like a prisoner's dilemma. Somebody is going fast in a car. The brakes are failing. Okay. There's a mother carrying an infant or a toddler in a pram. If it just goes and hits, the mother and child will get killed. But on the left side, construction workers are working because they are fixing the road or something. So whether you will go and hit the mother and child and kill them, or you'll go and hit the construction workers and kill them. In any case, you have to kill somebody. Otherwise, the vehicle won't stop. What will you do? So this is the way he answers this question. 10,000 people will be there in his class. You will put all this in. The way he explains, and he has written a lot of books, The Tyranny of Merit and all that. He's considered a very important contemporary American philosopher. Okay, maybe about 65, 68 years old. So you can even take a Coursera or edX, I don't know, some course if you're interested in this. Of course, this is arts. This is not even science. This is arts. So Michael Sandel, just Google up Michael Sandel's lecture, this moral side of murder. Millions of people might have already seen. Okay, all. Also, as engineers, we should not be always, I keep telling you, always you should not see how to write a bigger code, how to learn more. That's all okay, fine. There should be some portion of your time where you should read something and get familiar with the subject. It is totally unconnected with mechanical engineering or something. It could be any other thing. It could be even painting, craft or something. Suppose you look at economics, philosophy, all this. The funda there may be some brilliant thought, and then or some procedure or some way of doing something. Can you bring that to your own field? Invariably, if you see people who have made a change in this world, are the people who have looked at many things, who have tried to bring the best practices from elsewhere. Okay, so keep your eyes and ears open. Don't buy some book, read something which is non-fiction, which is not connected to mechanical engineering, which cannot be put as a bullet point in your biodata. Let it be a condition. Everything need not be to put a bullet point in biodata so that you can prepare a better SOP. Forget, okay, put your SOP somewhere, you'll get admission. If it is not that university, next level university, it doesn't matter. Do something for which there is no reward. You just enjoy, you want to do it. So you want to learn something, you want to progress. Instead of trying to quantify that and say whether I will get a better placement, whether I will get a better university. Okay, that's all okay. But full life, 24/7, we should not be doing something. There should be something where the rewards and prices do not matter at all. I want to learn it. I'm enthusiastic. I'm keen. I want to do it regardless. Okay, I'll do it regardless. I'm not saying regardless, dash, 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 you fill up all right? Okay, now, other forms. Okay. Okay. Problem number. What will be the problem number? Tell me the problem number for this. 8 or 9 or what? Huh?
Eight, sir.
8. 8. Consider a proposal for a linear fit. Consider a proposal for a linear fit for y in two variables x1 and x2. Consider a proposal for a linear fit in y in two variables x1, x2 as given below. Okay. Please set up the least square regression equations for the above proposal. Okay. Please set up the LSR equations for this. Is the question clear? 3 to 5 minutes. Then I will tell you what is the motivation. Why in thermal sciences AX1 plus BX2 plus C is important. Okay. Oculot everyone, dear all, blah, 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 attendance. If anybody is ready, just come on chat. So the next class will be on Monday. Next Thursday is the quiz. Next week we'll have 3 lecture classes and 1 quiz. You'll just have 2 questions. Obviously, 1 question will be in regression and regression and inverse. Okay, that is 1 question. 1 question will be on statistics. So it will all be roll number specific. We'll have enough time to finish. Okay. So during the weekend, just buy A4 sheets of paper and write your name and roll number in every sheet and keep it. It may be useful for other courses also. Set up your, clean up your scanner app, Adobe scanner, Cam scanner, whatever. I think if you take photographs and then assemble, maybe it's too big. The file is too big. Okay. So just paper, pencil, class notes, paper, pen, class notes, calci, A4 sheets. That's it. And at and internet at the beginning and end of the quiz. That's all. No, not even at the end of the quiz. Internet at the beginning and internet when you submit. This way it is hassle free for you. You don't have to travel anywhere. From the comfort of your homes, you can solve. There's no pressure on time. We give half an hour more than the quiz time. So if somebody is a slow learner or somebody cannot do fast, it may be better than a regular class in IIT because you can take 5 minutes, 10 minutes. The extra half an hour, you can use it for solving itself. The last 5 minutes, you can scan it and upload. So it's up to you. So I think slowly we should create situations where time is not a variable. Because in real life, you will always get some time. You can always tell your boss, sir, I will do it tomorrow. So continuously, that's why for 300 years, we have done many things without questioning. Why should all the tests have one time limit? Why can't there be something where there is no time limit? Then we should, at least this is the first step. So in IISc, Professor G.S. Srinivasan used to tell me, Balaji, in IIT, your problem is, he's IIT BTech Mechanical, 69, gold medalist. Okay, he's a collaborator, he's my mentor. He's 73 years old, 20 plus years more older than me. But he always says, the problem with IIT is always test the speed. It's okay for JEE, you want to select somebody. Throughout life, if you keep on testing speed, life is not 100 meters dash, right? So if somebody takes 10 minutes more, what happens? What will happen? Will heavens fall down? But we don't have patience. We have the next class. We have to schedule. That is the problem. Okay. So at least this one benefit of this corona is that we are able to do something like this, which I've been trying to do for a long time. Okay. So S equal to huh? Is it okay? Can somebody come on audio and tell me it's okay? Is this okay? Hello? Hello, is this okay? Yeah, somebody should tell me. Is it okay? Please tell me. No, sir, it's not okay. Something you tell me. Rajesh, is it fine?
Yes, sir.
Subhash? Subhash?
Okay, sir.
Okay, very good. That was Suraj, huh?
Yes, sir.
I'm doing an inverse problem. From the way you say, okay, I found out it is Suraj. But my algorithm will fail if there is somebody else who says it the same way. Okay. So, but don't worry, we will ask. Ideally, we should ask this question. But y is a function of x, ax plus b, 6 data points, you took 20 minutes. Suppose I give this, it will take a long time. But maybe in the end sum, we should ask. Huh? We should ask like this. Okay. So, okay. No, sir, why are you doing this? It is input dry mathematics stuff. Okay. You can copy this. I'll just wait for a minute. So the motivation in thermal sciences. Example, turbulent flow inside a pipe. turbulent flow inside a pipe. Okay. Okay, the pipe is of diameter D. It is length L, it is fully developed. So there is a fluid with a velocity um. It is Ti. There's a flow rate of m dot. The flow rate is, the specific heat is Cp. Then it comes out at, we call it as bulk mean temperature inlet, bulk mean temperature at the outlet. M dot is the same, steady state. The goal to get Q, so that we get Q. What is that H? This is the heat transfer coefficient. Heat transfer coefficient is a fundamental quantity of interest in convective heat transfer. Nusselt number in heat transfer is known to be Hd by K of the fluid. So, if you have a relation for a correlation for Nusselt number, we know what the thermal conductivity of the fluid is. We know the diameter. This is known. This is known. This is known. You can get H. From H, you can get Q. If you get Q, you have solved the problem of convection. So you have solved the basic problem in heat transfer. Okay. Now, from theory, also from experiments. Reynolds number of the fluid and the Prandtl number of the fluid. Okay. So the Reynolds number of the fluid is um d by mu, and the Prandtl number is mu by alpha. Okay. And it is also known that the Nusselt number is A Reynolds number to the power of B into Prandtl to the power of C. You remember the famous Dittus-Boelter equation. Nusselt number is 0.023, Reynolds number to the power of 0.8, Prandtl to the power of 0.4 for heating, Prandtl to the power of 0.3 for cooling of the fluid. Okay. So if this is equation 5, if you take ln of nu, to take ln of A plus B ln of Re plus C ln of Prandtl. So y equal to C plus AX1 plus BX2. That's what we wrote in the class. So if you do an experiment where you varied the Reynolds number 6 times, you took 6 different types of fluids. So you've got 36 data points. From these 36 data points, if you regress y equal to C plus AX1 plus BX2, then take the antilog of C, you will get the A. And this, instead of, I think this is confusing. Huh? Okay. Now, if you put it in this form, you can just, whatever you have done in today's class, with that you can solve the problem of convection. Now, to get this correlation, there are many ways. So, to get the 36 data points, you can do a full simulation. Okay. Or you can do experiments in the heat transfer lab, whatever it is. Once you have the data, you can use this to get a correlation. Where does data science enter the picture? Suppose for various Reynolds number, various Prandtl numbers, you also have various surface references, various kinds of features. You've got past data of, you are in a company which is doing heat exchanger business. You've got past data. Then without bypassing the physics and all that, if you put the input as Reynolds number, Prandtl numbers, a relative roughness, blah, 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 all that. On the right hand side, if you put the Nusselt number or heat transfer coefficient, if you're able to divide the data set into training, testing, and validation, Professor S. Balaji will speak about it later. You test it on 70% of the points, and remaining 15 and 50, you use it for testing and validation. Then you can bypass. You can bypass this correlation business and straight away go to neural network. So there is a big potential even in a field like thermal sciences, which is very traditional, which is very classical, that based on extensive data available in the past, you can recorrelate, you can recreate the whole of heat transfer by putting the correlations as neural networks. That is one. And secondly, you can also use neural networks to solve the governing equations itself. That's what Professor S. Balaji is trying. We call it as physics informed neural networks. This is the latest. Everybody is beginning to work on this. Okay. The other possibility is just to do simulations, and instead of a correlation, have an alternative proposal. Okay. You start experiments afresh, or you start calculations afresh. Generate the heat transfer data. Instead of a correlation like this, use a neural network as a proposal. This is one way of doing it. Second way, you don't even have to do experiments or simulation. There's so much data available with you. Use that in a data science framework and get a correlation from the set number. Option number 2. Option number 3 is the stud and the high funda, where the original equation of convection in a pipe, you try to attack it based on some limited data. You try to attack it using a physics informed neural network. What this is, Professor S. Balaji will teach you in April. Shall we close for the day? I've already taken 5 minutes more. Any doubts? Is it clear? Somebody should say fine.
Yes, sir.
Fine, sir.
Okay. Thank you. So I'll take some hot coffee. I will try to fix my allergy problem in a day or two.